All right, and this is a pretty big topic, understanding a reference angle and being able to apply it quickly. So a reference angle is two words. It's positive and acute. A positive acute angle. So we all know what positive means, correct? How about acute? Less than 90. Okay, so your answer has to be less than a 90-degree angle. Okay, it has to be positive and acute, less than 90 degrees. The easiest way to find it is to find the degrees of separation with the x-axis. And I'm going to circle this x-axis. Not the y-axis, the x-axis. How far you are from the x-axis. So let's draw a little sketch off to the side. Okay, we've talked about this several times now. This would be 0 degrees. Okay. How much would this be? How many degrees have I gone from here to here? 90. I'm going to ignore that for a minute. How about to here? 180. When if I made it all the way back around? 360. Okay, I didn't write 90 and 270 down for a reason. We are only talking about how far we are from the x-axis. So you are either using 180 or 360. Okay, it's how far we are from the x-axis. So if you look at this diagram in this first quadrant, okay, right here is the reference angle. This is how far it is from the x-axis, right? So let's put in r theta. How far I am from the x-axis. In the second quadrant, this is the main angle. This is not the reference angle. This is the main angle. The reference angle is how far I am from the x-axis. Now you might be thinking, well, this is a distance to the x-axis, but it's not what word? It's not acute, Sarah. That's right. So this is the reference angle. How far I am from the x-axis, but I need to be acute. I need the small one, the less than 90. In the third, okay, this is my main angle from here to here, from the initial side to the terminal side. But the distance to the x-axis is just this little piece here, the acute angle to the x-axis. And then same thing here, my main angle went all the way around, but my reference angle is just this angle here to the x-axis. So let's think mathematically how do we get that. This one is just itself. It's already a number less than 90 if you're in quadrant 1, yes? So you're already a reference angle. In this quadrant, how am I going to get this reference angle? If this is the main angle, and this is 180, how far am I from 180? What would I do? Subtract from 180. I would just do 180 minus my angle. They're going to give you the angle. Yeah. And then you'll figure out the reference angle. All right, let's think about this one. If the angle was here, how am I going to get the reference angle this time? Do who, Rohan? I just didn't hear you. I don't know what you said. Oh, yes. Why can't I use 270? That's the y-axis. We can only use the x-axis. So I have to do something with 180. What would I do with my angle in 180? If I add them, I'm going to get something way bigger. Subtract who? The angle minus 180 this time, yes. Because that angle is bigger than 180, right? So I have to do the bigger one minus 180. If I'm in this quadrant, how am I going to get this reference angle? I need the distance to the x-axis. How am I going to get this? From what? You got it, yes. So 360 minus the angle. Okay, I can only use the x-axis. All right, so let's apply some of these. It says, sketch the given angle and state the reference angle. So let's make a quick sketch. Where do I find 125 degrees? Quadrant 2. All right, so here's initial side, terminal side. This is 125 degrees. Is 125 a reference angle? No, it's not what? Not acute. All right, so I have to get my reference angle. That is this side, how far I am to the x-axis. What am I going to do to figure this distance out? You got it. Hopefully that's just common sense. We wrote it up here as a formula, but hopefully you're thinking that through. That's 180. That's 125. So 180 minus 125. What does that get us? 55. So I'm going to put equals reference theta, reference angle. Okay. It's positive, it's acute, it's a win. It's got to be less than 90 degrees. All right, 250. Where do we find 250? Quadrant 3. So I've got my initial side, 250. Okay, so that's an angle of 250. That's not a reference angle, it's not acute. I need to go to the x-axis. So here to the closest x-axis, how big is this angle? What am I going to do to get that? You got it, 250. Take out the 180. 70 degrees is my reference angle. That's this guy here. Okay, now, in trigonometry, we almost never use degrees. We think degrees because it's something you've heard of before, but almost all trig is done in radians, and we talked about radians yesterday. Okay, so this is pi over 3 radians, pi over 4 radians. If it's easy for you to convert it to degrees, by all means go ahead. So let's take a minute, that was on the quiz. If I want degrees, who am I multiplying by? You got it, 180 over pi. Okay, we'll try to stretch our brains here. What's going to cancel? Pi's. Can I clean this up maybe? The 3 and the 180 make a 60, and 5 times 60 is 300. So that's, just to be clear, that's not the reference angle. That is not a positive acute angle. Now I'm going to draw out my 300. Where do I find 300? Quadrant 4, so initial side, terminal side. If that big angle is 300, how far am I to the x-axis? 60 degrees. 60 away. Now here's the deal. If they give it to me in radians, my answer has to be a radian. I can't leave it in degrees. I now have to convert 60 to radians. That was on the quiz too. What am I going to multiply by? Pi over 180. What I want goes on top. That's all we practiced yesterday. All right, let's clean that up. What happens to my zeros? Cancel. And the 6 and 18 make a 3. Where's that 3 going? Top or bottom? Bottom. Do you notice the correlation between our reference angle and our main angle? They both have the pi over 3. Do you think that's a coincidence, or is it going to happen every time? I think it's going to happen every time. So if I see a 5 pi over 3, I can hopefully think right away that my reference angle is going to be pi over 3. We're going to work it out, but what do you think the reference angle is here? Pi over 4. Let's see if we're right. So let's take 5 pi over 4 and turn it to degrees. Let's multiply by 180 over pi. Okay, my pi's can cancel. Okay, you can do, and again, you don't have to clean up how I do. You can do 5 times 180 divided by 4. That works, or 5/4 times 180, whatever works for you. What's 5 pi over 4 turn out to be? 225. Okay, so let's go ahead and graph 225. Where do we find 225? Quadrant 3, so initial side, terminal side. Okay. How far am I, this is the reference angle, how far am I to the x-axis? What am I going to do to get that? Minus 180. What do we get for a reference angle? 45. All right, let's convert that back to radians. 45 times pi over 180. We can do a little mental math here. Let's think about this. How many 45s make up a 90? 2. And how many 90s make up a 180? 4. So that just becomes pi over 4, which is exactly what we predicted, right? See that correlation? That's going to be huge coming up. Recognizing the reference angle from this given angle. Okay. All right, let's try number 5. So we haven't done a negative angle in a while. Where does the negative angle take us? Clockwise. It's going to go backwards. Now think, you want to go backwards 220 degrees. What quadrant does that put you in? Did you say 2? Yep, I think that's right. So this would be back 90, back 180, back 270. I want to be between 180 and 270, so I think I'm going back to negative 220. And why can't that be my reference angle? It's not what? It's not positive first, and it's not acute. Both of them, right? It fails both. All right, so I still need the distance to the x-axis. Would you still agree that's this section here? All right, how am I going to get the difference from here to here? Sure, you could add 180, or you could just take positive 220 minus 180, right? You just want the difference between the two. So what's the difference between 220 and 180? 40, negative. No, well, it has to be a positive acute, right? So our reference angle is just 40. Okay, just make sure your answer is always positive and acute. Pi over 4, anyone want to guess the reference angle? Why, Payne? You're right. If you knew the reference angle right off pi over 4. It's giving it to us, okay. All right, if you don't know what pi over 4 is, we can easily convert it to degrees. All right, so it is less than 90. 180 over pi. Okay. And again, what's 180 divided by 4? 45, right? You can so you should be able to picture 45s in your head, right? If this is a 90, how many 45s make up a 90? 2. So out of a pi over 4, or out of 180, we should know that that makes up 4 45s. Okay? So this is already 45 degrees, which is already in the first quadrant. So not only is that the main angle, it also happens to be the reference angle. It is already positive and already acute. It is itself. It's in the first quadrant. All right, you got number 7, negative pi over 6. Negative pi over 6. Put it to degrees, go ahead. What's pi over 6 in degrees? Negative 30, right? Okay, so I'm going to go backwards 30. Which quadrant does that put me in? 4. So here's my initial, here's my terminal. I'm going to go negative pi over 6, which is really negative 30 degrees. What does that make my reference angle? Has to be positive. It'd be 30. How far am I from the x-axis? I am 30 degrees away, or pi over 6. All right, let's do some mental math time here. Don't flip the page yet. This is coming up, so we might as well get a head start. All right. Let's go back to, let's do this. I'm going to stick a circle on here. This is how many degrees we said? 0. This is 90. This is 180. And back to, okay, that should roll off everybody's tongue very quickly. We're counting by what? Counting by 90s. Okay. Now, let's convert these to radians pretty quickly. We should know that 180 is the same as what radian? Pi. That's all we did yesterday. We said pi is 180, right? We discovered 3.14, right? We measured out a radian, and we said 3 and 0.14 made up pi. And what do you multiply when you convert degrees to radians? You multiply by pi over 180, or 180 over pi, because they're equivalent to each other. So pi is 180. What was 360 then? How many pi's? 2 pi. Okay. All right, now, if pi is 180, how much of that is 90? Half pi. We just like to call that pi over 2. Okay. Now let's go to 270. Think about this. How many 90s made up a 270? 3 90s, which would be 3 pi over 2. 3 of these make up 270, so 3 pi over 2. So I have 0, pi over 2, pi, 3 pi over 2, 2 pi. This is coming up. This is all we're going to be talking about. We're not going to be in degrees anymore. It's all going to be radians. Okay? Let's take another one we know. If I cut this in half, how many degrees did we say that was? 45. Okay? How many radians did we say that is? How much, okay, when if I split this up? How many 45s are in a 180? 4, so that would be pi over 4. Does that make sense? Okay, so 45 we need to know is a pi over 4. 90 we need to know is a pi over 2. 180 is a pi, 3 pi over 2, 2 pi. Eventually, within the next week, before our next test, okay, you have to know every point on here in degrees and radians. It's not going away. Okay, and then everything gets converted to radians. We start graphing these crazy functions. It's all in radians. You have to really understand these radians. Okay, so let's do this again. Don't look at my previous work. But it's very logical, so it should make sense. So let's just talk degrees. How many degrees is this? Everybody say it. 90. Back to. Okay, so degrees simple. Now let's talk radians. Let's do the easy one. What pi is equivalent to what? Oh, I just said it. Son of a gun. 180 is equivalent to pi, which makes 360 how much? 2 pi. So 90 is how much of pi? Pi over 2. And how many 90s get me that 270? 3 pi over 2. Does that make sense? Super logical. Like, this isn't like a mind game. Like, it should be very, very logical. Let's talk our 45. If I cut this in half, I get a 45, right? How many 45s made up that pi? 4, so 45 is pi over 4. Okay, let's think about this. Give it to me. So we're just adding to the picture now. 3 45s, right? This is 1, 2, 3 45s. The radian would be 3 pi over 4. That's right. When if I did 5 45s? 5 pi over 4. When if I did 7 pi's? See how simple that is? Like, we're just counting by pi over 4. Okay, super logical as you're going through and thinking these through. Is your brain hurting yet? Why are you laughing at this? You're laughing at Stephanie, I can see. All right, let's see. I'm going to let your brain rest for a second. Flip the page. And I'll give you a few minutes to get started on this. We're going to do it right on here. I'm just going to walk around and grab these again. Label each reference angle with r theta and then find r theta. So remember, you're looking to see how far you are from the x-axis.